Good morning, everyone. Welcome to your heat transfer experiment number 1, measurement of thermal conductivity value of two different materials. In order to do this experiment, we were trying to use the famous Fuller's law of conduction and 3 equipment here. This is the HT10XC service unit. We're going to use this service unit multiple times in the future, also for another 4 experiments. And the linear heat conduction module and the constant temperature water bath. First, let's connect those devices. We need to connect the power cord to the power outlet. This is the power cord of the service unit. This is the power cord of the water bath. This is the power cord for the heater over here. We need to connect this one to the back side of the service unit. Now those 3 devices has been connected. Then we need to turn on the switch. There's one switch on the back side of the water bath. Turn this one on. And there's another switch on the front. You also need to turn on this one. I already preset the temperature value in the water bath to have 20 degrees Celsius constant. Please do not change any of the setup. You just turn on those devices. So this constant temperature water bath will be able to provide 20 degrees Celsius cooling water circulating on the bottom part of this linear conduction module. Okay. And so that's the water bath. Now we also need to turn on the service unit. This is power on. And then we need to connect the thermocouples from the linear conduction module to the service unit. There are total 8 thermocouples on those linear conduction module. Thermocouple number 1, 2, 3, thermocouple 4 and 5, thermocouple 6, 7, and 8. Let's first connect all the thermocouples to the service unit. Those thermocouples, they're labeled with numbers. Number 1 thermocouple, you need to connect to T1. Also, the thermocouple has 2 pins. The one that is a little bit large is going to be the bottom part. So this is a thermocouple number 1 connected to T1. And thermocouple labeled with number 2, you need to connect this to the T2. As I said, you need to put the white pin on the bottom. So this way. Do the same for T3 all the way to T8. This is how we connect the thermocouple to the service unit. So this is the setup. It's ready to use for doing the experiment. Let's start our first test. The first test is a measurement of a thermal conductivity value of 25 millimeter brass sample. So what we need to do is try to sandwich this one, the sample, between hot layer and cooling layer. Now, the hot layer, we have, this is the electrical heater. Electrical heater actually embedded in this like insulating material. This is a plastic material. So this is the insulating material. We have 3 thermocouples to measure the temperature gradient. We have 2 more thermocouple in this 25 millimeter brass sample. Okay. And we have also the cooling layer. Remember, as I just mentioned, this is going to be 20 degrees Celsius constant water temperature. So we will assume on the bottom, this is going to be constant 20 degrees Celsius. On the top layer, we're going to have constant heat transfer rate. So now let's sandwich this one. You just clamp this. That's it. And also on the back side. So now this is the first sample already been sandwiched in between the constant heat transfer rate layer and also constant temperature layer. Now we need to give some input to the electrical heater. The unit actually I already turned on. Okay, so now we need to set up the voltage. Remember, you need to refer to the menu, different group. You will have different voltage input. For example, group number 1, your input voltage is going to be 5 volts. And also group number 2, your input voltage is going to be 5.5. Group number 3, your input voltage is 6 volts. Okay, so every group, as you can see, as the group number increases, the input voltage increase 0.5 volt. Okay, so refer to that menu to find out the input voltage for your group. Let's try the first group voltage input. So I'm going to input 5 volts. How do you input the 5 volts? Number 1, you need to turn the indicate knob. This is the indicate knob. As you can see here, I have the V, I have the I. V means the voltage. So you need to let this indicate knob pointing to V. Means right now the reading over here, that's the voltage. So how do I change the voltage? We have a voltage control knob. So you can turn this clockwise and counterclockwise to adjust the input voltage. I'm going to put the input voltage to be 5 volts. So I'm turning actually clockwise. So this is 5 volts. Okay. Once you have the input voltage been set up, you can also get the input current. Turn the indicator knob to I. I means current. As you can see, this reading is going to be the current value. This is going to be 0.49 amp. So now you have the input voltage and current. If you use the voltage multiplied by the current, this one is actually the input to the heater, electrical heater. And this value, 0.49 amp, multiplied by 5 volts, that's actually also the constant heat transfer rate from the top layer to the bottom layer. Okay, that's how you apply the famous Fourier's law of conduction. Q equal to K, that's thermal conductivity value, multiplied by A, cross-section area, multiplied by temperature gradient, delta T divided by delta L. So the Q now is going to be a constant, come from the voltage multiplied by the current. So you also need to know the cross-section area. Actually, as we said, the diameter of those samples, either they're going to be 13 millimeter in diameter, or either they're going to be 25 millimeter in diameter. So you can calculate the cross-section area. Now, how do you get the temperature gradient? The temperature gradient measured from the thermocouple. Remember, we have thermocouple 1, 2, 3, 4, 5, 6, 7, 8. They're connected to the service unit. So when the temperature becomes stable, so another question is, how do you know the temperature now is going to be stable? We need to turn to the temperature knob. This is the temperature knob. Turn this temperature indicator knob to any T1, T2, and T3. You will be able to read the temperature value. Let's say, for example, right now this is pointing to T1. So this one will give me the temperature value. Right now is 25 degrees. What you need to do for turning, if this is going to be the constant steady state, constant temperature value, is trying to monitor this temperature value. If this temperature value does not change for about 90 seconds, so we can call this a steady state, then you will be able to collect the data. So to get the steady state, usually you have to wait 20 to 25 minutes for each temperature or each voltage setup. So right now, this is going to be the first sample sandwiched in between the hot layer and the cooling layer, and we have the thermocouple being connected. Now I can check the temperature value. So this is the temperature value of T1. I turn the temperature knob. This is going to be a temperature value of T2. That's the temperature value over here from thermocouple number 2, and the T3 all the way to T8. If you accidentally turn to T9, which will give you a reading equal to 148 degrees Celsius, something like that. Do not worry about that. This number actually means the thermocouple is not connected. As you can see, this is T9. We only use the T1 to T8. T9 is not connected. So every time you notice something like this, there's nothing wrong. Okay. So this is how you read the temperature value. When the temperature becomes stable, as I said, you have to wait probably 20 to 25 minutes. Then you can start collecting the temperature value T1 to T8, and also the voltage and also the current. So this is going to be your first set of data. Then you need to change the sample. Let's say now let's try the second sample, 30 millimeter brush, sandwich them again between the hot layer and the cold layer, clamp them, and do not change any of those setup, voltage, current, and also the connection, just keep as you already set it. And now wait for another 20 to 25 minutes and let the temperature to become stable. Then you will be able to collect a second set of data. Then change the second sample to the third sample and wait for another 20 to 25 minutes. That's going to be your third set of data used for post-lab calculations. And that's going to be your first experiment in heat transfer. That's it.